Good afternoon. I am Manette Njike. I will present a part of my PhD thesis. It is already published. It is about potential of straw gum block as construction material. The interest of using straw bale as construction material has increased due to the need of developing building material that are climate responsive, and also because straw can significantly reduce building energy consumption during their life cycle. The advantages about using straw bale is that they have low embodied energy. They also have good thermal insulation properties. They are cheap at low cost, and also they are lightweight construction. Some inconvenience is that they have low compressive strength, about 0.02 megapascal, and this has led to the fact that you cannot use it for more than one single-story house, construction of more than one single house. Also, there are high deflection that is displayed in the bale when they are compressed, and this displacement ranges about 32 to 90 millimeter. This displacement can create failure of structure. That's why before the walls are plastered, there is a stage of pre-compression. The bale also have large thickness, and this reduces the floor surface area. The sizes are not also regular. They are different from companies. The concern about straw bale house is about the durability and the fire resistance. We all know that straw is a biomaterial, so it can degrade under certain conditions. Also, they can also be eaten by insects, or they can easily be burned if they are just in the loosened state. Because of the problem with moisture, it has been regulated that the high moisture content in the bale should be 20%. This has been published in the International Residential Code. It has also been concluded that engineers they should use good practice guidelines when they are doing construction. In solving the problem of fire resistance, it is true that a loosened straw, dry straw can burn easily, but when they are compressed together in a ball, they become tight and they cannot, it is difficult for air to pass through it. We all know that for fire to exist, we need heat, we need fuel, and we need energy. Then, if those walls are plastered, for them to be burned, the fire has first to burn the plaster before it is the bale are attacked. This is how straw bale houses are constructed. We see that this first figure is straw bale. Here you're having one-story house and just a house plastered with soil mortars. Straw bale has a dimension of 750 millimeter length, 500 millimeter width, and 350 millimeter height. The technique of construction of straw bale is a bit complicated. Before everything is done, you have to ensure that on the lower running bone there is a plate, a hood plate. The bales are jacked one on top of each other without plaster or without mortar joint. And then when you are done with the wall, there is another plate that is put on top, and some tensioning wire are used on those two plates, the one down and the one on top, to compress the panel down. There is a wire mesh that is also used on it to increase the strength of the wall. Then plaster is applied on it. That is what this image is showing. To understand the behavior of straw bale house, we have first to conduct compression tests on the single straw bale. And we have realized that straw bale is not a brittle material because it doesn't fall under in the compression loads. What happens is that when we apply load, it compressed the material by pushing out all the air that is included in the void. And then when everything goes, all that air goes out, that's when this bale starts to gain stiffness. And this is at a high displacement in the ball. So if you don't compress it well, under construction, that displacement will still, that void will be there. So we have also conducted tests on scale model bale, and we have realized that the same phenomenon happens. When the ball is not compressed, it has a height H0. When it is compressed to maximum, it has the height reduced. And then when the load is removed on the bale, in some time, after some time, when air filled all the voids in the bale, it goes back to its initial height. This means that the problem with straw bale is not only its strength, but also we have to find a way to bind the material together so that on the construction, you don't have all those movements. Like when people are working on it, it's compressed. When they are not on it, it goes back. You will be having a movement in the block. So we also conducted some tests on plastered straw bale. The first one at our left is a panel that was not plastered. We tested it to see how it behaves. We have also plastered one panel with cement mortar. And the third one here is the one we use wire mesh to see the difference, how they behave on the load. So this graph is showing us the behavior. The blue graph is the straw bale. The orange graph is the straw bale panel without plaster. The gray one is the panel with plaster. And the yellow one is the one where we use wire mesh to reinforce the strength. And when we observe, we see that straw bale panel, they gain their strength due to the plaster. So this plaster adds strength. Even the wire mesh, it really adds strength to the panel. Now, because we want to remove that height, that displacement in the bale, we find which type of gum or binder can we use to enable those particles to remain together. We investigated like cow dung and gum arabic, and we found that gum arabic was the best because it flew easily through straw steam, and it was in a liquid form. The proportion gum arabic water was 1:1. So this is the process of straw block construction. We use the gum arabic, we blended it, we mix it with water in the proportion 1:1. Then we chopped some straw, we mixed the chopped straw with the binder, and we formed this block that we are seeing on the machine. From that block, with some time on this first image, we see that they don't have the same shape. So they expand because even gum arabic is viscous, so it expands. We find a way on this image too to find a mold, a wooden mold that will keep that shape. Even when we use it after ejecting the ball, we see that there is still a swelling. So we concluded that it is good that we place some blocks on the formwork. So these blocks was resting on the mold, not on the material that you are trying to dry. So this is how they look like after 1 week. This image 4. So after 1 month and even half, we demolded all those blocks, and 3 types of them were made. The first one here was wheat straw block, because we use wheat straw block, and this was only the mixture of chopped straw with binder. The second one was still The type 2 was with straw block with sawdust. We tried to put some fine aggregate particle in the blocks to see how it behaves. The last one, block type 3, we blended those two at a small length, less than 1 centimeter, and we mixed with a binder. Because it is after 1 month. Before we unmolded one block, because why did we stay for long before we even conducted test? Because we've realized after 14 days, even though the blocks look dry at the outside, but the inside part of it is still so wet. You see how gum is leaking. This one is after 1 month and a half. We cut the block and they were dry enough so that we conducted. We conducted compression tests. We were just investigating the primary engineering property of straw block. Compression test was conducted. This was manual. Water absorption and initial rate of absorption, and thermal conductivity using the method flow. The results we obtained are presented in this table. If you see in the last column here, we see that they all have, the 3 types of block have the same compressive strength because the machine was manual and the load were applied at the same instrument. And due to the fact that those blocks had the same dimension, it can only give us the same compressive strength. However, the displacement in the block were different. For the block type 3, we had lower displacement, that was 29 millimeter. The water absorption, before 24 days, all the blocks dissolve in water. But for the initial rate of absorption, you see that it was 0.1, which is acceptable, and the thermal conductivity was 0.06 watts per meter Kelvin. And the thermal conductivity is good. It is smaller than that of concrete. Yes, this is the stress strength curve of those 3 types of blocks, how they behave. They behave the same way as a straw bale. You see the one in blue is straw bale. The one in orange is block type 1. The one in gray is block type 2, and the one in yellow is type 3. We see that as fine particles are put in, are added, is compressive strength, the displacement in the bale reduced. So it means that to have a good block, we have to fill all the gaps that is found in the straw steam. Even by blending it, we see that it still have displacement, but it has the displacement has reduced compared to the straw bale. Even the compressive strengths are also increased compared to that of a single straw bale. When you compare the behavior of straw block with brittle material, you see that they don't look alike because for a small applied load, there's a high displacement in straw block or straw bale. And also, it does not behave like a ductile material, but however, it behaves like an elastomer. Those blocks were used, generally, let's say block type 1, because that's what we produce first in high quantity. Block type 1 were used to construct this house. And 3 types of mortar was also used. The first one was also cement, only cement mortar. The second one was cement mortar with a partial replacement of cement of 25%, another one partial replacement of 50%. We have conducted a test and we saw that the one with partial replacement of 25% show the good result. So those are the results you are going to here. We see on this load displacement that when straw blocks are plastered using that partial replacement mortar cement with partial replacement of 25%, it carry more load compared to, this is the gray graph, this is the plasterable panel. The orange is the straw block panel that was not plastered. Now the blue one is the straw bale panel plastered while using wire mesh to increase the strength. And the yellow one here is just plastered straw bale panel. We see that even unplastered, straw block has more strength than plastered straw bale panel. And also you can see that on the it can carry 50 kilonewton load. That means that the load carrying capacity, if we divide that 50 with the dimension of the panel, we'll have 297 kilonewton per meter square. This load carrying capacity is far more greater than that of a slab on a residential house. So that using gum has really increased. This is the strength. This is the failure pattern of those blocks. We see the first one where cement plastered were used. The cement just split on the wall without any, no bond. It was not presenting good bonding. And this one was the one where 25% gum arabic were used as partial replacement of cement. That's where bonding was really good, even when we were doing bonding tests. So we observe also, we can also say here that if cement mortar is used to plaster these straw block houses, the block can be used after destruction. We can still use the block because when we remove this cement, the block was just still intact. We can use it again in another construction. Yeah. As conclusion, this is how straw bale look like, and this is the straw block that we created. In conclusion, we see that using gum arabic help in holding the straw stem together and form a compact material that improve the compressive strength of straw bale. We also concluded that straw blocks have good shape, they are regular, and also they are similar to the conventional block that we normally use in houses here in Africa. And during construction, we don't require too much of qualification to be doing the pre-compression. We just use it and then we plastered. And we recommended that straw block can be used for construction of single-story house. We did not want to go more than what the International Residential Code have said, that it is one-story house, because we have not conducted any prototype houses with more than one floor to see how it behaves. Good. Yeah, further research question is that we can do the prototype house and see how does the straw block house behave after a long period, maybe 1 year. Can it carry 2 slabs? We see. Then if it carry only, because that was a load-bearing panel, it means you can use it even to build even 10-story houses if they are not structural materials. And we also try to see what is the best way to dry straw block, because you can see that it takes a long time to dry, and we create a lot of delay in construction. And finally, we are trying also to see what is the best way to improve the stress strength of straw block, because we have seen that that's a good material for construction. Yeah, those are the published articles. Thank you.